So hello everyone. I am Wesley Chun. I'm a developer advocate at Google. I'll be able to. There should be enough time for a quick demo and Q&A at the end. But in case we run out of time, here is a barcode and a short link to an open Google Doc that I have, so that people who are attending my presentations can ask questions. Maybe like a week or so later, you forgot you had a question, or you just came up with a new one. Feel free to jot them in there. I check that document from time to time, and I'll answer. It is an open document, so just be aware. But the good news is that you can also go into seeing what other people have asked in my previous presentations as well too. So anyway, that's an open resource for everyone. My Twitter is here, and today I'm going to talk to you about serverless computing with Google Cloud. All right, let's get started. A little bit about myself. As a developer advocate, my main goal is to enable all current and future developers everywhere to be successful using Google Cloud and other Google developer tools and APIs. My main focus is on our cloud platform serverless products, which I will be talking about all three of them today. And I also have secondary areas that I focus on, and that is higher education, which is why the "and future" is bolded. I also work with the Workspace team, so most of you know that as the collection of Gmail, Google Drive, Calendar, Docs, Sheets, and Slides. I also have some expertise in our machine learning APIs, and then multi-product use cases. So my background is I've been a software developer for several decades, worked for some pretty well-known names, but probably the most well-known thing that I built was I was one of the original 10 engineers that built Yahoo Mail about 20 years ago. So that's still being used today. And outside of work, I teach, and I am a member of the Python community. All right, so let's discuss what we're going to talk about today and why. So the main idea is that cloud computing has taken industry by storm, and I would argue taken over all industries, because from no matter whether you're in real estate or you're in retail goods, consumers, it's really not just technology companies that are using the cloud now. Everybody is. And so a pair of my colleagues gave a discussion about app modernization, and it is a top priority at many enterprises. Things including like containerizing apps, scanning them on VMs, and eventually moving them to the cloud. So serverless is something that you run into as you get towards the latter part. So if you remember my colleagues' presentations earlier, they had a little section for run, where you run your code. So this is the area that I'm focused on. But one thing I do want to ask everyone to start thinking about ahead of time is, obviously as a cloud vendor, of course we have virtual machines and big disk, but really why would you consider serverless? And the main reason for that is that it will let you focus on your solutions and not necessarily what they run on. And really it's just to sort of like bring everybody together and having that cloud knowledge, so that, regardless of what industry you're in, what point you are in your career, if you know something about cloud, that can only really help you moving forward. So as far as the rest of the talk goes, I'm going to start with a high-level overview of cloud computing. I know everybody here on the call already knows what cloud computing is, but sometimes when you get into conversations in the hallway, you ask one person, what is cloud computing? They say one thing, another person says something else, and a third person says something else as well. And in reality, all three of them are right. So let's kind of normalize the vocabulary so we all know where we're talking about, we're all on the same page, and then we can move forward to discussing what Google Cloud is, what kind of services we have, and of course, the main reason why you're here is to hear about our serverless platforms, and then perhaps see some inspiration as to like what kind of things you can build with our platforms. We'll wrap up and hopefully have some time for a Q&A as well as a quick demo. All right, let's get started with all you need to know about the cloud. So what is cloud computing? Mainly the concept is you're outsourcing things that you don't want to be responsible for, or your organization doesn't want to be responsible for. Like outsourcing hardware, storage, and even applications. And one example that I like to give when I speak is a very popular one, which is email. Everybody knows how to use email. It's been around for a long time. But in the early days of the internet, in order to send and receive email, everyone had to have an email server or set of servers running on whatever machine or workstation or PC that they have, in front of them. And it has to be connected to the internet, because who knows when you're going to get email. So and then as the internet became more prolific, it really wasn't expected to have grandma managing SMTP on port 25, right? I mean, that's not really kind of like a nice thing to do. So instead, most people have chosen to outsource their email service to a third-party vendor, a cloud vendor like, Yahoo for Yahoo Mail, Google for Gmail, and Microsoft for Hotmail, right? We all use those services instead of having to manage our own servers. So that's really the main idea. And then so when you get deeper at talking about cloud, generally all cloud services are divided up into three major service levels or pillars, as we like to say. Email goes up at the top. That is a software as a service application. Basically, it's any kind of application that you've outsourced. So the outsourcing of apps is SaaS. Anytime you need to go to a web browser and log into something or on your mobile phone, that is a clear sign that you're using a SaaS app. So in addition to email, you're going to find things like Google Docs and Google Drive, Gmail, Office 365, Salesforce. Those are all examples of SaaS apps. Now, notice at this level, you don't really care what programming language it's developed in. You don't really care what operating system is running on. All you care about is that it's available for you when you need to log in and check your email or use a document or whatever. Okay, so that's SaaS. At the very opposite end of the spectrum is infrastructure as a service. So this is, all your VMs, all your big disk. This is what, these are the kind of services that most major cloud providers provide. And of course, it's great because it's computing power. I don't have to buy the hardware anymore. I can just lease it or rent it from these well-known cloud vendors. Now, one thing that I want you to think about is if your purpose of renting VMs is to run applications on, I'm going to ask you to pause and rethink that strategy just a little bit, because what happens is just getting the VM is not necessarily good enough to run your app, right? You have to worry about all these other things in between. So before you can deploy your app, you have to decide on what operating system. Do I choose Windows Server? Do I choose Linux? And if the latter, which distribution and which kernel version? And then so once you settle that, then you have to decide what database should I get? What web server should I get? So there's a lot of other things that you have to think about before your application code runs on top of it. And by the way, this goes for everybody's applications. They have to make those same decisions too. So instead of renting a virtual machine, I'd like to ask you to consider platform as a service, which is kind of like a sweet spot in the middle. This is where, yes, I'm going to run my applications on it, but I don't have to think about all of those other things. I don't think about VMs or how many nodes I need. I don't think about the operating system. I don't think about the database. It should be available for me, and so that I can focus on the code. All right, so that's platform as a service. Now, with any large ecosystem like cloud, of course, there's going to be gray areas in between, and cloud is no exception. So in between infrastructure and PaaS, we have services that are more than just the raw hardware, like infrastructure, right? But they're not quite full PaaS systems. You can't really upload code to them and run them because they're not for applications. Generally, at this layer, you're going to see, some people call this DBaaS or databases as a service, but it's not just databases. It's also data processing, data analytics. You'll find networking stuff here. You'll find containers here. Again, everything that's more than just raw hardware like VMs and disk, but not quite an application platform that you can upload code to and run. All right, so that's that. In between PaaS and SaaS, you have what I call restricted PaaS systems. All right, this is purely, me making this up, right? So these are PaaS systems, but the thing that differentiates them from their more general cousins down here is that AppScript and Force.com generally require you to have some kind of data that live at the SaaS level. So AppScript is great if you have Workspace data, and of course, writing Force.com app is great if you have Salesforce data, but if you don't, it would probably be better if you use a more general purpose PaaS system so that you're not sort of like locked into having to have data at those in order to take advantage of those systems. All right, so that's that. And then one last thing I want to note before we move on is just to be a little bit aware that when you're using a PaaS service, when you're uploading code, you're actually creating a SaaS app for your users. All right, so let me give you a quick example. That is, if you're using Gmail for your email at home and you find a bug with Gmail, you can't fix the bug yourself because it's not your code. It belongs to the cloud vendor. So you have to file a ticket with Google and have one of our engineers fix it, right? Again, at that level, your users don't care what language is written in, what operating system it runs on. They just care that their thing works. And if it doesn't work, they have to file a ticket with you. Notice that when you are using our PaaS systems to deploy your applications, guess what? Now you're creating a SaaS app for your users. So when they're having a problem with your app, they have to file a ticket with you because, again, they can't edit the code because it's not theirs, it's yours. All right? So just be aware that PaaS systems are used to deploy SaaS apps with. Okay, so now you must have a really good idea as to these major cloud levels. Now let's look at it one last time, but turning the tables just a little bit and looking at it from a slightly different perspective, which is the perspective of who's responsible for what. Okay, so when you're using software as a service, you've outsourced your apps. If you're a user, you're not responsible for anything. The app's already there. Your cloud vendor is responsible for that email system. Google is responsible for Gmail. You're not. The only thing you're responsible for is, maybe your personal settings, like your email signature and things like that. If you're using a PaaS system, it's your code and the data that goes with your applications, right? Everything else you've outsourced. If you're using infrastructure, you've outsourced all the hardware, but you're responsible for everything from the operating system level on up. And of course, if you're not using the cloud, you're on-prem, you're responsible for everything. All right, so this is another way of looking at cloud computing, but from the perspective of who's responsible for what. All right, and with this overview, we are done and ready to move on to introducing all of you to Google Cloud. So what is Google Cloud? Google Cloud is a large organization that employs myself as well as some of my colleagues. We have two major product lines. The first is a cloud platform. And the second is Workspace, which used to be called G Suite, which used to be called Google Apps, but everybody knows them by Gmail, Google Drive, Calendar, DocSheet, Slides, and associated tools that go with that. All right. Most people think, oh, cloud platform, yeah, it's VMs, it's APIs, it's for developers, and then the Workspace stuff, it's for users because it's, like Gmail is applications and stuff like that. But public service announcement that, while Workspace has all these well-known applications that you're used to or have heard of before, don't forget that behind every single one, there's usually a developer API. So anytime you see this symbol, it just means there's an API somewhere. And we also have a serverless platform too. So I'll mention this one at the end. I'll use I'll discuss the cloud platform ones first before the Workspace one. So anyway, just be aware that developers can also use Workspace. Alrighty, now where does Cloud Platform and Workspace fit into our little model of cloud computing? So anything generally that's SaaS flavored belongs to Workspace, and then anything else below that is GCP. So it's a pretty clear delineation. So you just smell it, and if it smells anything like SaaS, that belongs to Workspace. All right, cool. Now, GCP offers a lot of different computing options, and this is not even including Workspace stuff. This is just GCP alone. So moving from left to right, you're going from lowest level to highest level. Generally, there's a lot of wobbly in between. And of course, I don't have time to talk about all of them, but I'm going to focus on all of the services which are fully managed, which means you don't think about instances, you don't think about nodes, you only think about your code and uploading your code and having it served by our hardware. All right, and you can access this chart at the link down below in case you really want to go back and take a deeper look, or if the font is too small and you can't read it. All right, cool. Now let's discuss Google Cloud Serverless Tools. So back to sort of an original point that kind of raised earlier but didn't dig into it, and that is, again, we have VMs and big disk, but so why would you consider something else? Again, if your purpose of getting this hardware is to run applications with, I'm going to ask you to reconsider. Okay, it's great that we have all these VMs. You can get anything from a small F1 micro, which is free for all users every month, all the way up to a monster machine with 416 vCPUs, almost 12 terabytes of RAM, and 256 terabytes of disk. That's not a cheap machine. I think it's like between 80 to 90 US dollars every hour. So it's not cheap, but if you need to have it, then you can go and get it. And of course, our VMs support most major distributions of Linux as well as Windows Server. And of course, we also have big giant disk in Google Cloud Storage. So you heard that in the previous talk as well. This is your giant data lake because all of your data rivers flow into your data lake, right? Your big blobs. But again, this is great infrastructure. However, I have to worry about too many other things in addition to my app, and I don't want to do that. So let's think about serverless. So what is serverless? Yes, it's a lie. Well, okay, I don't want to say it's a lie. Let's say, let's call it a pedagogical represent a misrepresentation. All right, so I'm doing it on purpose. Of course, there are servers. The main idea is that it's not your problem. It's not something you have to think about. And it lets developers, just worry about the solutions they're trying to build for themselves or for their customers. Now, why would you consider serverless? According to analyst research, and I'm actually curious to see what 2021 ends up being. I think it may be greater because I think the pandemic has accelerated the use of serverless, in my opinion, but I don't know. I'm not an analyst. But when they did this research a couple of years ago, they noticed that the corporate spend on serverless has been doubling almost every couple of years, and it's projected to continue growing at that accelerated pace. Other reasons to consider why serverless is, like when you talk to your senior engineers, your CTOs, they always tell you when you're solving a problem, solve the 80-20. Make sure you get 80% of all the use case, and then, worry about the corner cases that in V2 or V3, or don't even think about them. One of the cool features about serverless is that it can also handle some of that 20. So for example, if you go viral, if you are a startup, and you didn't spend enough money buying hardware or renting hardware, if you go viral and it impacts your system, your new users are not going to be happy at some point because they can't reach your system. Then your existing users that got you there aren't going to be happy because they can't reach your system either. That's not good for your business, right? So one of the cool things about serverless is that within Google data centers, we have code that watches the traffic that your app is getting, and if your app is continuing to get more and more traffic, we will just spin up more instances of your app in a horizontal way automatically, where you don't even have to think about it. You don't need to wear the pager anymore because you don't have to, it's not a problem for you anymore. It's our problem. Right? And then similarly, the opposite is also true. Let's say you're a startup, but you spent most of your VC money buying hardware and not enough on engineers to actually build your solution. Well, that's not good either, because if you spent all this money on the hardware and you're not getting any traffic, that's also a bad sign, right? One of the coolest things about serverless is that it scales down to 0. And not even VMs can do this, because if you have at least one VM up, you're paying for it 24/7. But serverless does auto scaling to 0. And if you're getting no traffic, you don't have any instances up. And if that's the case, then you're not incurring any billing, which means you're not paying. So that's some of the reasons why you would consider serverless. Now, as far as what we're talking about today, lots of services that Google Cloud provides, it can be considered serverless. If you are renting a SQL server in the cloud using Cloud SQL, you are not responsible for the server that's running SQL Server or MySQL or Postgres or any of that. And all these other services that we have in Google Cloud, you're not responsible for the hardware either. So they can also be considered serverless. However, since I'm talking about the run part of app modernization, we're really focused on serverless compute, which is sort of like the golden hexagon that you see in the middle. And generally, that applies to anything that's PaaS flavored, more than like slightly more infrastructure-oriented serverless tools like Cloud SQL. So that's why it's a paler, it's more sickly yellow than the orange for serverless compute. All right, so that's that. Now let's talk about the platform. So Google App Engine, that is our first cloud product. It represents app hosting in the cloud. So why does App Engine exist? Years ago, our developers, our product team asked engineers around the world, what is a thing that is preventing you from launching your system globally fast? Right? And they said lots of things, and mostly those things are represented by these brown boxes here, like the operating system, how many machines they need, monitoring, security patches, web server, load balancer, all those different things, right? And also, I have to be able to deploy globally. I need to have machines around the world, and I want it to be managed by somebody, and I want it to be auto scaling like I was describing before, because I may go viral. And if nobody's using my stuff, I don't want to pay for it, and also make it available in very common languages, because I want to be able to hire folks off the street that know Java or Python or PHP, and I want them to get going right away. So really, that is the sort of like the origins of how we came up with our very first cloud product ever. So our product teams took all these little brown boxes and jammed them into one large box, called it App Engine, made it available in lots of well-known programming languages. And here's your first code sample. So this is the world's smallest web app. It's written in Python. It's what we call the minimal viable product. So the smallest web app you can create has 3 files. You have a configuration file that specifies, what version of Python this, for example, this is going to run, or it could be Node or whatever. Then we have our web app itself, which is just prints hello world when you go to the website. And it uses a popular micro framework from Python called Flask. And since that's a third-party tool that doesn't come with Google Cloud, it's available on GitHub. You have to give a package requirements file to show like what kind of packages does my application depend on, so the system can automatically install those before running my application. So those are the 3 files. As soon as you have these, whatever, altogether it's like 7 lines of code. Then you can install the Google Cloud SDK, which comes with the gcloud command. And on the command line, developers can type gcloud app deploy, and then in roughly under a minute, typically, your app is available globally around the world at a specific URL that you're given. That is based on your project ID. Of course, if you have a company and a custom domain, you can always point to it. It's pretty easy. So this is our Python App Engine Quick Start, but again, we have quick starts available in all the languages that are supported as well. So that's it. That's pretty quick. And if we have time, I'll demo this. I'll actually run gcloud app deploy, and in under a minute, I'll be able to access it at whatever appspot.com domain I have. All right, so we'll do that. Next product is Google Cloud Functions. This is function hosting in the cloud. So this is where maybe you don't have an entire app, or maybe you don't want to worry about stacks. You just have like small little bits of code, microservices or functions you just want to have online so that maybe your mobile app can call it or whatnot. So like App Engine, it can be triggered by HTTP, but there are a couple of features that Cloud Functions has that App Engine does not, and those are all bolded. So one of them is background events. You can actually make a Cloud Function run based on getting a message in Cloud PubSub, which is our message queue service, kind of like Apache Kafka, if you've used that before, or if somebody uploaded a file to cloud storage, or if they logged into Firebase or anything like that. So that's one of the cool features that Cloud Functions has. Like App Engine, it's auto-scaling and highly available, and you're only paying if somebody's calling your app or your code. We support lots of different languages, just like App Engine does. We have a very flexible work environment. With App Engine, you do have to be on the command line to deploy, but with Cloud Functions, you can do everything in the developer console. So in the Cloud Console, you can create a Cloud Function, you can code it, you can deploy it, and you can test it. You can do everything in the web browser, or you can use the Functions framework and develop and test locally, and then upload it to the cloud. Also, I wanted to let you know, you can see 2 icons. So we actually have 2 different versions of Cloud Functions. The blue one, which is Google Cloud Functions, is mainly for you to use if you want to access other Google Cloud services. The other one is for mobile app use cases. This is a customized version of Cloud Functions for Firebase. Firebase is our mobile development platform. And if all of your apps need to access other Firebase features, then you would probably be using Cloud Functions for Firebase. So just be aware that there's 2 different versions. Great. And then as far as Cloud Functions goes, compared to all the other compute services, it is the fastest to get up to speed. You don't have to think about frameworks. You don't have to think about configuration files. You can get things working in Cloud Functions very, very quickly. So this is just kind of a chart that some of our user researchers have done to show people who have never heard of this product before, how long does it take before you actually have running code in Google Cloud. And so this is kind of like a rough averages. So just take it with a grain of salt, but it really is to indicate that Cloud Functions is very easy to create and deploy. So here's your MVP in Python. It's a one-liner. How fast can you get, right? How short can you get? Does the same thing as the other one. And deploy is a little bit longer because you no longer have a config file, so you have to specify more things on the command line. So instead of gcloud app deploy, it's gcloud functions deploy, the name of your function, what language you're using, and how you want to have it triggered, because again, Cloud Functions can be triggered on different background events. I'm just going to do the regular HTTP so that again, like App Engine, under a minute, I should be able to curl to it from the command line, or I can point a browser to it. And that is our Python quick start for Cloud Functions. All right, last one is CloudRun. This is our container hosting service in the cloud. So we all know, being an industry, that containers have gotten extremely popular over the last decade. It has great features that serverless does not have. You saw the last 2 serverless products where, oh no, you have to use Python or Java or PHP or Go or Ruby or JavaScript. But what if I have an imaging library that's in C++? I can't do that, right? I can't use serverless. I must use a container because a container gives me the flexibility to use any language, any library, any binary. And of course, I can throw in whatever I want into the container as well. And since then, containers have become an industry standard as far as application deployment goes, as far as like a logical unit representing apps. And Docker and other systems provide a very large ecosystem of base images that support every possible type of application. So really, I love the flexibility of containers, but I can't ignore all those exciting conveniences that I just told you about, which is I don't have to worry about operating systems. I don't have to think about not paying if I'm not getting any traffic. I like auto scaling to 0. But some of these serverless features make it inaccessible to me. Like, I really do want to use C++, or I don't want to feel like I'm locked in, or I want to use binaries. How can I happen? Why do I have to choose between the flexibility of containers and the convenience of serverless? Why can't I have both? And that's really what led to the creation of CloudRun. Since CloudRun supports running containers in the cloud serverlessly, you can use any language, any library, any binary. The only thing we ask of you is that you open an HTTP port for us so that we can call into your container, and also you have to make it stateless. So instead of having like a built-in data store within your application, you really need to call out and put your data in the cloud so that if your app is called multiple times because traffic and retries, things are down, that it doesn't have adverse side effects on your application or its data. Then you can take that and bundle all of your application into a Docker container. You can use regular Docker commands if you're familiar with that, or you can use Google Cloud Build, which basically just wraps the Docker commands. It sticks them into our version of the image registry, which is called the Cloud Container Registry or Artifact Registry. We have 2 of them. And then once it's in there, then you can deploy to CloudRun, whether you want fully managed, like what I'm talking about here, or GKE, or using Anthos and having it in a hybrid or on-prem mode. And then finally, CloudRun also supports GitOps, which is push to deploy from Git. So once you make a check-in, it can trigger a cascading chain of events that leads to your new code being deployed on CloudRun. You can also do CI by adding, features in front of it like GitHub Actions or other CI integration mechanisms, and altogether you can make, Cloud Build and CloudRun part of your entire CI/CD pipeline. All right, so here's your MVP for CloudRun. So this is, it's almost identical to the App Engine one. In fact, it is identical to the App Engine one. There's a couple of infrastructure lines on the bottom that are really not necessary. I should probably just take them out, but yeah, it's the same app. The only difference is because it's in a container, I have to provide a web server now instead of using App Engine's web server that comes by default. And I also know I said this support, CloudRun supports any language, any library, any binary because it's a container, but we only have quick starts in these 10 different languages. Okay, so you can check out that link to get that quick start. Of course, generally when you have a container, there's typically a Docker file that tells it how to build a container, and you probably should have a Docker ignore that says filter out this stuff because I don't want this junk in my container because it has nothing to do with how my container runs. And then what you do is you can do gcloud build submit to basically build your container and then push it into the container registry. So that's the same thing as like Docker build and Docker push. And then finally, you can do gcloud run deploy. And that's like Docker run, where you're taking an image that's in the container or artifact registry and deploying it to CloudRun to have it run. There's also another command which is more for convenience. So this is where maybe you don't want to do all this stuff. I don't want to do it in 2 steps. I just want to do one push to deploy. So you can do this one command instead of these 2. And what this will do is this will cause your source code to be built into a container and deployed. So it's all 3 of these Docker commands in one: build, push, and run in one command. And then just like App Engine and Cloud Functions, in under a minute, your app will be available globally at a weird looking URL, which you can always point a custom domain to. However, there's one more bit of news before we leave here, and that is, guess what? We have a new feature that makes it so that knowing about Docker or having to maintain Docker files are completely optional, and that is called Cloud Build Packs. So Build Packs is an open standard from the Cloud Native Computing Foundation started by Heroku and Pivotal. And this basically helps you build your containers without having to know about Docker files, because it introspects your code to figure out what language you're using. It checks to see what packages you're using, and it goes and sort of like builds its own dynamic Docker file on the run and then builds your container from that. And one of the cool things is it doesn't matter what it is. Like I have an Express app in Node, same command that I have for my Python app. You don't tell it anything different. It just goes and figures out this is Node, this is Python, and it's going to build a container and deploy it to CloudRun. However, one tricky thing is build packs only supports a certain number of languages, so you have to make sure you do that. Otherwise, you do have to have a Docker file. So you can learn more about build packs as well as deploying with a single line command from these 2 blog posts. By the way, I'm providing the slides for everybody at the end, so you don't have to worry about taking screenshots, and just pay attention. So you can learn more about build packs from its GitHub site as well too. Okay, so as far as when do you use which, these are sort of checkboxes that are kind of gray because it could be anywhere. I mean, there could actually be checkboxes in almost every single one. However, what is more common? When would you use App Engine versus CloudRun versus Cloud Functions? So typically this is what we've been seeing, but everything is subject to debate. And I'm going to save the demo for the end just to make sure we have time for it. But when I do give the demo, it's going to be this single app. And the reason why I have this app, or why I created this app, is because a lot of people are asking, well, I don't know the differences between the two. Or if I start on App Engine, can I move it to CloudRun later? Or any of the other ones. So what I did was I wrote a mini Google Translate app. Just converts English to Spanish. And you can deploy this app 8 different ways, and on all these platforms. So you can deploy locally and have it run. You can have it deployed to App Engine. You can have it deployed to CloudRun, or you can deploy it to Cloud Functions because it's a very simple app. And you can move them between the different platforms just by tweaking the configuration a little bit. So that's the demo I'm going to show at the end if we have some time. Let's move on to the last one, which is AppScript. It is a customized serverless JavaScript runtime to help you with automation, really, and it helps extend integration with Workspace, but it doesn't have to be. You can use other Google services or even non-Google services as well. And really, this service is meant for this serverless platform is meant for the business developer, the data analyst, not the full stack software engineer. And instead of using APIs to talk to, like instead of using HTTP and OAuth and APIs explicitly, the way you access Google APIs through AppScript is by objects. So if you want to talk to a Google spreadsheet, you would do spreadsheet app dot and a bunch of things. So this is a one-line JavaScript application that will write hello world into cell A1 in your spreadsheet. I just broke it up into 4 lines so you can see it easier, but it really is just 1 line of code. So you save it and run it. By the way, a lot of new developers today, especially collegiate students, don't know why this is a save button. So I usually have to spend time explaining that to them, but I know you all know what that is. So anyway, once you accept the permissions for that code to get access to your spreadsheets, you will see a spreadsheet that has hello world in it. And it's really fascinating or exciting because guess what? You didn't type that in yourself. You actually wrote code to make that happen. And so I made a video on AppScript if you're curious about it. But yeah, so that's one thing, but not really a useful piece of data. What about a spreadsheet that actually has real data like this address? So I can explode that app from 1 line into this 4-line application, okay, that touches on other Google products to do something hopefully more useful. So first line of code, I'm going to connect to the spreadsheet. Second line of code, I'm going to go back and grab this address out of cell A2, save it in this variable. Then I'm going to say, hey, Google Maps, can you make me a new map and put a pin on this or a marker on this address? And then line 4 is, hey, Gmail, can you email this map to my friend so they can come join me for lunch at the Google New York office? All right, so 4 lines of code. It touches 3 different Google products, but it doesn't have to be Google products. I can use JDBC to talk to any relational database. I can use URL fetch and talk to any other online service. So I'm not just tied to Google, but you can see here and get a flavor that this can talk to services outside of cloud, like Google Maps and YouTube and analytics. So it's much more useful of a tool and it's more broad. I made a video on this one too. And then I also, for developers, I made a code lab so you can build this app line by line. Although there's only 4 lines, really most of it is explaining what each line does. All right, so what you can do with that? Well, you can take this 4-line code and build it into a more useful app, like maybe I want to visit my 4 top customers in Manhattan, or maybe I'm managing a book club, or maybe I have a user group. I can expand that app to manage all these things. I can use a Gmail API to send notifications. I can use the calendar API to drop events in their calendar. So lots of different possibilities using our APIs. All right, so to wrap up, some other apps that I think I'm only going to go through like 1 or 2 of these because we're running short on time. So I just want to make sure that we get through the presentation. So Just going to do a couple of them. So one example is one of my colleagues wrote an app that added custom intelligence to Gmail by analyzing Workspace data from GCP. So what did he do? He says, oh my gosh, I get so much email. Gmail does a great job of filtering out my spam, but even with my non-spam, I only care maybe about a couple of messages, and I only care about ones that have attachments with pictures of birds in them. I know this sounds kind of funny, but let's run with it here. So what did he do? He wrote an app so that anytime he got a message in Gmail, it would drop a message into Cloud PubSub. Again, that's our message queue service that will kick off a Google Cloud function, which will extract the attachments from that email message, call the Cloud Vision machine learning API to analyze what's in that image. And if bird is one of the images that comes back from that, he will call the Gmail API and star that message. So without running any code explicitly, the next time he logs into his Gmail, he'll see that some of his messages have stars next to them because they have attachments with pictures of birds in them. So this is just an example of a very, one thing that you can do. So if it's interesting to you, you can read the blog post or get the code sample. And the last example I want to talk about is going from big data analysis all the way to slide presentation by going the other way from my colleague's app, which is now I'm accessing GCP tools from the Workspace side. So big data is everywhere today. We need to have great tools. And of course, we have Google BigQuery, which is our data warehouse and data analytics tool. So you can do all of your work in here and get these great results in the web UI. But is this presentable to your manager? Because the only thing you can do is download a CSV. Well, CSV is not very pretty. It's like these stairs. I did 80% of the work. I did the hard work by getting, analyzing the big data, and I can use it, but it's not that presentable. If I'm going to go to my management, I want to put it into something nicer to look at, like a spreadsheet. And if I'm using Google Sheets, why don't I tell the API to make a chart on it? And if I'm going to make a presentation, why can't I extract that data into a slide as well as that chart I just made? In fact, why don't you just build me the entire presentation from scratch? So that's what I mean by the last 20%. You did the hard work, but why don't you do the rest of the 20% so that you can go straight to a slide deck? So this is an AppScript app. I'm going to run it, which calls Google BigQuery. I get the results. It goes into a sheet. I tell Spreadsheets to make a chart. Then I create a slide deck. Then I import the chart and the data into it. And then boom, I have gone from big data analysis all the way to exec-ready slide deck. And if you look at the code and remove all of the comments, this is less than like 100 lines of JavaScript. It's very small. So you can learn more about this at the video and blog post here, or build this line by line, or explain it to you there. And to wrap up, resources. People often ask about cost. So Google Cloud has a free trial. It's good for a quarter, so $300 US for you to play with our cloud. But we also have an always free tier that continues forever after that. The free tier is a daily or monthly quota that you have to exceed in order to have to incur billing. If you never exceed our free always free tier, you never have to pay because we're not going to charge your credit card. So you can read more about those there. As far as our serverless products goes, App Engine gives you 28 hours of free a day, as well as 1 gig of data storage and networking. And then CloudRun and Cloud Functions give you 2 million calls per month. And there's also a certain number of free memory and CPU seconds that you get, as well as networking. So there's a lot of free stuff. And just to wrap up, so why go cloud? Cloud computing is everywhere. It's really not too late to get into cloud. And if you do choose Google Cloud, why would you consider serverless? Because we have lots of compute and storage power, as well as machine learning and data processing. But serverless lets you focus on just your logic and not have to think about what it runs on. And there's also interesting possibilities if you actually use both parts of cloud together. Okay, I don't have time to go through all these, but Google, of course, has lots of different APIs you can consider. I would suggest that you take a look at some of these, depending on the type of applications you build. Some more links as well for you to learn from. And of course, the last slide and the most important one is where to get the slides. So there's a link and a short code. Again, there's also a barcode and a short link to for the Q&A afterwards. And I did give this same talk to another event earlier in the year. And so if you completely forgot about everything I just mentioned, then you can go review that. And if you all notice the progress bar is down at the bottom, neither PowerPoint nor Google Slides has a progress bars feature. So one of my colleagues built it using AppScript, which was the last serverless tool I told you about. So it's pretty awesome. My daughter says hello, and I want to say thank you, and I'm going to hand it back to Ron